Okay, this is exercise 6b, calculate the length and arc of a circle. You've done this at GCSE with degrees, but it's a lot easier when that angle there is in radians. So there's our arc, which we're going to call L. You've got two arcs in a circle. That little one is the minor arc, and this one, the Pac-Man shape, is the major arc. So we're looking at the minor arc, which is subtended by those two lines, which are the radius. Okay, and we're going to call it L. So we're going to look for a formula then that allows us to get that length of the minor arc. Okay, what we're going to do is we're going to compare the length of that arc to the length all the way around the circle, which we know is the circumference. We know that's 2 pi r. Okay, so we're going to compare that with the circumference, and then we're going to compare that angle there, which is theta, with the angle right around the centre of the circle, which we know in degrees is 360 degrees. But in radians, that is 2 pi. So it's a distance right around the outside, right around the centre of the circle. Okay? So just going to use those two facts. And then we're going to use a bit of proportion. Alright? So we know that if we take the length of the arc, so L, and we divide that by the circumference of the circle, so that's 2 pi r, and that fraction we get, that proportion of the minor arc and the circumference right around the outside, that's going to be the same as the fraction we would get if we divide that angle theta, which is making the arc, with the angle around the centre, which is 2 pi radians. So those two proportions will be equal to each other. Okay, and that 2 pi is because it's the angle around the centre of the circle. So all we do now is we just cross multiply, take the 2 pi r across the right hand side. So therefore we've got a formula. The length of the arc is going to be equal to theta divided by 2 pi times 2 pi r. As you can see, look, the 2 pi cancels with each other, leaving us with such a simple formula. If you cast your mind back to GCSE, when you did this topic, length of arcs of circles, it was far more complicated than this. You're going to end up just multiplying the radius and the angle by each other. Okay, really efficient formula. So let's do a quick example to show us how easy that formula, L equals r theta, is to use. So to find the length of an arc of a circle of radius 5.2 centimeters, given that the arc subtends an angle of 0.8 radians at the centre of a circle. Okay, so all that means is our diagram is going to have a sector with an angle of 0.8 radians. Alright, the two straight edges are going to be 5.2 centimeters, and we're looking for that minor arc, which is created by the 0.8 radians angle. Okay. So that angle there is going to be 0.8. Now two straight sides, obviously the radius of the circle, so that's 5.2 and that's 5.2. And we want to work out L. So literally all we do is we multiply the radius and the angle by each other. So L is equal to r theta. So therefore L is equal to 5.2 times 0.8. Couldn't be easier. So therefore, the length of our arc is 4.16 centimeters. And that's been rounded to 3 different figures. Okay, easy. Okay, now as that one's so easy, let's do something a bit more complicated. We've got a minor arc, AB of a circle, with centre 0 and radius 10 centimeters, subtends an angle x. The major arc AB subtends an angle 5x at the centre. So find in terms of pi the length of the minor arc AB. So let's get a little diagram which represents that question then. So if we just draw a small sector, so that's going to represent our minor arc. Alright? So think of it as a Pac-Man shape. The minor arc is the mouth of Pac-Man and the major arc is the head of Pac-Man. So the minor arc is subtending an angle of x. So that's that one there. And the major arc is subtending an angle of 5x. So that's the major sector of the circle. So the major is the bigger, the minor is the smaller. Alright? So this does look like it could be a little bit complicated because we don't know what the angles are. Okay, we know what the radius is. The radius is 10 centimeters. But we need to work out what that angle is. So if we add those two expressions together, 5x plus x, that's going to be equal to 2 pi. Because remember, the 5x plus x is a full turn, and we're dealing in radians, so a full turn is 2 pi radians. Remember, 2 pi is the same as 360. So that's 6x is equal to 2 pi. So x is going to be equal to, if I take the 6 across the other side, I get a third pi. Just take the 6 across, you've got 2 over 6, cancels out to a third. Okay. Now we often leave radians in terms of pi as well, because it gives us the angle a bit more accurately. And then, after we've done that, so that's the only hard bit of the question really, because now we just use L equals R theta. So L is going to be equal to 10 multiplied by a third pi. So 10 times a third is just going to be 10 over 3. So the length of the arc is just going to be 10 over 3 pi centimeters. Okay, again, slightly tough, but simple really. So let's see if we can do something a bit tougher then. And then, because we leave it in terms of pi, that's our answer done. Okay, and that's the accurate way to leave our answer as well. This example looks like it's going to be a bit tougher because it's a real life problem. So we've got a board and a garter pond consists of a straight edge AB of length 2.4 metres and a curved part C. Curved part is an arc of a circle, centre 0 and radius 2 metres. Find the length of C. So if we just draw a sector, so the only straight edge we can put in for AB, look, is going to be where the minor arc would have been. So we're looking at a problem involving a major arc then. We know that length AB is 2.4. Okay, it says the circle has got a radius of 2 metres, we can put that in. So the curved part of the garden pond is going to be that major arc. Okay, so we know we need to get that major angle at the centre as well. So it's a problem is we haven't got anything at all about the angles at the centre of the circle, okay? But if we work that angle out, if we take that away from 2 pi, we'd be able to get the other one, okay? Now, obviously we've got a right angle, we've got a triangle there, okay? So we can either use the cosine rule, or we could split it in half, and so it's into 2 right angle triangles, and then we could just use SOHCAHTOA. So you want to weigh up this at the moment, you're on what's going to be easier, cosine rule or SOHCAHTOA. Alright? Now, I'm going to be lazy, or what I like to think of is more efficient, and use SOHCAHTOA, because that's easier to use and less likely to make a mistake with. Alright? So let's just forget about that circle for a minute and just look at this triangle then. So we got x, that's side 2, that's side 2, that's 2.4. So what I'm going to do is split it in half. So I'm going to cut that angle x in half and create a right angle triangle. So that base of the triangle is going to be cut in half as well. So that means we're looking at half of 2.4. Alright. I've just labelled that angle A as well. And A is going to be half of x. So once I've worked out A, I'll double that, I'll get my x angle. And we move on from there. Okay? So that's what I've done to that triangle. So let's just draw out the one we're going to use now. So I've got a 1.2 sides, a hypotenuse of 2, and the angle A is what we want to work out. So I've got the opposite and the hypotenuse. There's the adjacent. So I've got the opposite and the hypotenuse, as I said, so that's going to be sine. So remember, sine of A is equal to the opposite divided by hypotenuse. So let's just write that out quickly. So that's going to be 1.2 over 2. So angle A is going to be equal to inverse sine of 1.2 over 2. Now it's really important, it's vital actually, that your calculator is in radians mode at this point. So if you haven't got it in radians mode, I'll switch off this video, look at the other one that shows you how to change it to radians mode, then come back. But that should give you an angle of 0.643501108. And I don't want to round anything until I get to my final answer of the curved length of C. Alright, so angle X is going to be twice as big as angle A. So let's work that out first. So angle X is going to be 2 lots of A. So X is equal to 2 lots of 0.643501108. Okay, now you'll be able to get away with just writing 4 decimal places and a few dots after it to show that you're actually using the full answer. Okay, you don't have to go into write it in full like I am in this video. So that's going to give us angle X, which is 1.287002216. Now at this point, it would be a good idea to look back at your diagram and read through the question again so we can remind ourselves what we've been asked to do. Now we've been asked to find that curved part of the garden border, the pond border. Okay, so we need that major angle at the centre, not the minor one. So we've worked out X, so now we need to work out that angle there. Okay, we know the full turn is 2 pi. Okay, so let's just label that with another letter so we know what we're talking about. So let's call that angle Y then. So we're going to need that, and then we can use our length formula. So Y is going to be 2 pi, take away 1.287002216. So therefore Y is equal to, just doing your calculator, it's going to be 4.996183091. So that's the hard part of the question done now. We've worked out that angle we need. So we can work out the major arc, which is the curved length of C. So now it's the easy bit. We just use L equals R theta. So L is going to be the radius, which is 2 times 4.996183091. Okay. And then just stick that into our calculator. Let's just move these out of the way. We're running out of room now. So therefore, the full unrounded answer is going to be 9.992366182. And that is the only number you should round in your problem, the final answer. Otherwise, if you round all the way through that question, look, there would have been 4 stages where we got rounding errors, which would have made our final answer a bit inaccurate. So you only round right at the end. So length of C is 9.99 meters to 3 significant figures. Okay, right, off you go then and have a go at the questions in exercise 6B.